And we are starting, okay?
Yeah, okay. It's on.
Okay. Yeah, it's on?
Yeah.
Just let me know. Okay, folks. Okay, we live?
Yes, yes.
Okay. Hello, everyone. Welcome to our next workshop. Today we have a very unique setup for those who join in online. If you have any questions, feel free to ask them in the chat on the YouTube. It's usually on the right side. So without further ado, we already lost some time. Sorry about that. We're gonna give the space to our workshop givers. And then if you have any question, me, Una, then there is Nancy and there is Julia on the first table. We are all organizers. That's our organizers team. So I will give the floor to Magda and to Petra.
Yeah.
Yes.
Well, hello everyone, also the joiners online. My name is Petra Gibcus. I'm a data scientist within a business data science team from the VSEOE. And today I will be hosting this session together with Magda Zych. She is a data scientist in the wealth management team. But we also have colleagues from the other teams in the audience. So before we really are starting, I want you to guess what's inside this black box. Maybe you're on the front, so...
I think Schrödinger's cat is in the black box.
Sorry?
Schrödinger's cat.
Oh, Schrödinger's cat? What's that? I have to...
You should check it. It's like quantum mechanics.
Oh, okay. Well, I'm not a physician. But yeah, if I open the box, then I can already see what's inside of it. But you can still can't. But if I pick a transparent box and I put it in here, you can see what's inside. It's chocolate coins. So, and that's also with machine learning models. A lot of them are black boxes, and you don't know what's inside of the black box. And you want to make them more transparent to be a glass box. And that's going to be the topic of this workshop, to learn you how to go from the black box to more like the explainable box. So I also have an example. So this is I have to be in front of my screen. This is an example from researchers who did research on image recognition of a husky and a wolf. And as you can see, 6 times, I only picked 6, but 5 out of 6 are predicted correctly. And the accuracy was also very high. But when they looked into the model, then they noticed that, hey, this husky is classified as a wolf. But it's only classified as a wolf because there's white snow in the background. So, white snow in the background, that's not the explanation we were expecting. You would expect that it would be based on the characteristics of the animal. So would you really trust this model? Well, we don't. So, and that's, you could have good predictions, but it doesn't always say that's a good model. So we think that creating a machine learning model is just one part of the data science equation, but also explainability is equally important. So why is it important for finance? Of course, we work in finance, you are the bank today. First of all, the insights need to be actionable. So our stakeholders do not only want to know to have good predictions, they also want to understand why it gets that predictions. And for bias detection, you can have, with explainable AI, you can correct, but also improve bias so that you have less bias. For example, based on age, gender, or religion. And as a bank, we have a lot of rules we need to apply to, especially from regulations. Also, we have to deal with GDPR. And with explainable AI, we are able to be more transparent also to the regulators, to be more compliant and also be more ethical. And fourthly, we think it's very useful in our work that people trust your predictions, because if they don't trust it, they are not going to use it. So yeah, for our stakeholders, but also for the customers in the end, it's very important. But we don't do it by ourselves in the bank. We work with a lot of people, a lot of stakeholders. You have to deal with compliance, ethics, privacy. So we all do this in co-design, and especially with the primary stakeholders. So we think your model will only really succeed in production if you do it with co-design with all of your stakeholders. So that's, for us, it's really important in our day-to-day work. So there are quite a lot of techniques you can use for explainable AI. And we're just going to mention a few of them. There are a lot more, but we don't have the time. So if you would like to know more about it, just Google your way or use ChatGPT, whatever. You can have a look yourself. Well, we just briefly discussed some of them. So first of all, there are the model agnostic tools. And this means that these tools are black box approaches. And they use the inputs and the outputs of the model. And the actual model itself and what's inside is hidden. And you can apply it to every model. So it's not really model specific. Examples are Lime and SHAP. And we will deep dive in this workshop more into SHAP. And on one of the next slides, I will also explain a little bit more about SHAP. Then you have more like the intrinsic methods. These are very explainable by itself because they are quite simple. So it's easy to follow them. An example a lot of people use is, for example, decision trees, where you have a node that represents a decision. The tree is the way to a decision. In the end, you have the leaf nodes, which are the final decisions of your model. But there are also many ways to visualize explainable AI. For example, you can use the SHAP dashboard. You can make a lot of plots on SHAP. It's very interactive. We just picked one here for the picture, but there are many you will also see and experience in the workshop. And then you have the partial dependence plot, which will plot your features against the model outcomes. And feature importance, I think many of you have heard of it. So that's also a tool you can use to visualize it. Most of the time it's visualized in a bar chart. And then, for example, for SHAP, you can also use clustering. In this workshop, you will also experience with that. UMAP makes the SHAP values reduce it to 2D. And then with HBDSCAN, you can cluster them. And with SkopeRules, you can finally easily see the rules. And it's for your stakeholders, very easy to interpret what's happening. So from SHAP, you go to the SkopeRules. So these are a few of them. And you will going to experience that in the dashboards. Magda will explain also more on that later on when you're going to do the exercises on it. So SHAP, what is it? I just mentioned it briefly. It's a method based on game theory that computes the feature contribution to predictions in machine learning. And the advantage is that it's both global and locally. Exercise 1, you can also play around with it. And SHAP stands for Shapley Additive Explanations. And it's a method that is made up by Lloyd Shapley, and he even won the Nobel Prize for Economics for it in 2012. So I will just show an example how SHAP works. So for example, imagine you are in a cackle competition. And you have two players, player 1 and player 2. And when you join together, then you win, and your prize will be 10,000 euros. So great. However, player 1 thinks, I contributed more to the competition, so I deserve more of the prize money. So normally you would split the prize money, but she thinks she deserves more. And C1, C2 is the coalition value for both player 1 and player 2. So let's do a little bit of a step in time. So if player 1 joins by herself, she will come second and win 7,500 euros. But if player 2 joins by himself, he will get only 5,000 euros. And of course, also none of them can join, so then the price is 0. So from here, you can already see that player 1 deserves more of the prize money than player 2. But still, how do you divide prize money between those two players? We don't know. And therefore, you can use the marginal contribution, which is the increase in the coalition's value due to that a player is joining the game. So let's calculate it for player 1. For player 1 can make a coalition with player 2. And then instead of being third, they will become first. So the increase will be 5,000 euros from 5,000 to 10,000 euros. Player 1 can also make a coalition with player with none of the players. So then the coalition values, the marginal contribution, increases to with 7,500 euros. And then you can calculate the expected marginal contribution. A lot of difficult words after each other. And that's the average of those two values. And so that's 6,250 euros. We can do a similar computation for player 2. And what you can see from this one is that it adds up to the 10,000 euros, so 6,250 and 3,750 euros. So now you know how to divide the prize money. And these expected marginal contributions are the SHAP values. So imagine you have a large data set with a lot of rows, features, and you can always compute the SHAP values. So now it's time to have you, for Magda to introduce you to the workshop, that you explore yourself how you can work with explainable AI and in particular with SHAP. We have that in the workshop. Yeah. Oh, no, we don't.
We don't.
No, we don't.
We're gonna
to that later.
Yes, so now Petra introduced us all these methods. Maybe some of you know what they do already, like how to use them. But what we're gonna do, we prepared with my colleagues a workshop for you. So now you can figure out how to use them. And it will make a mortgage churn use case. So in this use case, we want to predict when our customer plans to leave our contract with a mortgage on our bank. And we want to know who are those customers and what kind of common characteristics they have, what kind of group of people are they. So we do all of this to, of course, with the goal of our stakeholders and us to keep them with us because they will bring us more money. And during the workshop, we have 3 exercises. We're starting from just using our data set, exploring it and looking at what's inside, what are the general trends. And later on, there will be a ready set up model for you to run based on XGBoost. And after that, the fun part starts where we have the exercises. So in first exercise, you will just learn how to read the plots that are on the local level and aggregate it to more global level and how they reflect in our EDA. And this is a way to figure out how to audit our model and see if everything went as we expected. And then in second exercise, we will deep dive a little bit more to see like how features are interacting and see a little bit more what is possible for us. And finally, when we know all those basic information about SHAP and like what we can do with it and how it works, we want to think about this as, okay, we know how all of these plots look and we know how to interpret them, but what about business actions we can take from them? So then we're going to use the method that Petra mentioned to cluster our customers and see if they have these common characteristics that tell us that this is people that are more likely to leave us. So the data that we prepared for you is actually generated based on the publicly available yes, very hard word again, data set. And it is not representative at all of our customers and of our data. It is designed purely for this workshop. And it is already cleaned and nice to use, so we can focus only on explaining our model. And then it's also balanced. So we don't have to worry about imbalance in it, and just move on with predicting who's going to churn. And
Actually, it's perfectly balanced.
yes.
The half of data set has target of churn, and the other half is not churn.
Yes. Thank you. So what kind of features we have in this data set? It is things around our customers. So for example, what age they are. It is features about what kind of house they have. So in which city, if it's big, small, and also around their mortgage contract. So like how many years they have left until the end of the fixed rate period. So this is more or less when people are starting thinking about what to do next. And we have also information about how we interact with them if they are going on our website. So this is like 4 categories more or less of features we have there. And so now, finally, the password for our Wi-Fi. So you can open your notebooks and get the data and everything set up, start running it.
And the first one is a Y. So
Yeah.
Oh,
so it's Y 5AN RF BX and CD7. So
it's Y.
why?
it starts with a Y and not with a V.
First letter is Y. Watch out for this, please. And I think also the link to the repo.
Oh,
Oh,
So as soon as you get to the Wi-Fi, just let us know if you know where to find our repo. If don't, we will show you what it is. Okay?
yes.
If you don't know what the repo is, just raise your hands. We'll help you.
Perfect. Yes. So I will just maybe explain what is there, and when I will say what is in the first exercise, then we can go and help everybody that is in the room. Does it sound good?
I think let's first give the people time to connect.
Yeah. Okay.
Then to pull the repo.
Yeah.
And then we will go for it. Okay?
Okay.
Yeah? Yeah? Good.
do you want the repo on the screen?
Yeah, I think it would be really good if you just put it in. Yeah. I think it would, yeah.
And then it's here. Oh, I have to start. Can't see it on my own screen, so
Yeah, I think you can zoom in a bit.
so this is the repo.
Yeah.
Is it readable? On the top?
So there are 2 things you can do, and we put it in the README. Yeah. So you can use the Jupyter Notebook option, but also the Colab option.
Yes. So if you choose to use Colab, you just click the link and you can clone to your own directory on Google Drive the notebook. And if you decide to go with the workshop file on your own machine, just download, install all the packages. It is everything is as Petra said already. Oh yeah.
It's everyone gets Wi-Fi connected. Yeah? Okay.
Yeah.
Okay. And the second question, all of you right now, how to put in it? Yeah?
Please let us know if it doesn't work for you, then some of our team members can help you.
should unmute ourselves then. But I have to introduce the first exercise.
Everyone in the repo? Yeah? Is anyone not in the repo yet? Okay, I can switch the screen again.
Yeah, okay. So I'll just quickly say what we have there, right? Like you could see, you have the workshop file and you have the solutions file. And one of them always, if you want to see what's happening, you can always go to solutions. And there's an extended solutions, which you also described. So if you are very fast, you can always go there and like try to read more around the same topics. But now I will introduce quickly the what is in the first exercise, because actually it nice. Where is the okay, now it should work.
Now it works.
Yes. So you will see in the notebook, you have time to read everything through. We will give you 20 minutes for that. So you go from top to bottom, like installing all the packages. There's EDAs implemented for you, the basic EDA. So just run through it, read through it, so you are familiar with what you have. And there will be also model setup, so just read through it. And then when you go to the exercises, there will be the exercise 1, 1.1, 1, 2, and 3 is a bonus. So in the first one, you learn how to read the SHAP plots in the aggregated ones, and the second one is the local SHAP. And after this 20 minutes, I will come back to you and explain what we've seen. So yeah, I think it makes sense for you to just start on it and start working. And if you have any questions, our colleagues are everywhere. And yeah, let's just go on, I think. So, yes. Where's the mute? Oh, here. Yeah. Okay. We're gonna now move on with explaining what you did, most of you. The first exercise was to look into like how our model looks from SHAP perspective. So what we see here, so for everyone you know what we're looking at, this is the aggregated SHAP plots of our local explanations into one bigger one. And on what we have on the x-axis, like how important was that feature. So what is the SHAPly values? What are the SHAPly values per feature for the model? And they ordered from top to bottom, from most important to the least important. So we can see on the right side, for example, the most important was activity level, because that was our good model. But we also had this model with a very simple leaky feature, which was balance. That was information that what happened after the customer left. So we should not have this information in advance, right? So that's why the balance was here. It's on the first position. But what are the colors on these plots? It's also important to know is this actual feature values. So not the SHAPly values, but feature values. So we can see that in this balance exercise, we had the low values, so the zero balance on the account, right, was very important for predicting it as a churn. So on the right side, we hit when they were churning. On the left side, when they were non-churning. So when the balance was high, they were not churning. And when we want to compare these two plots, how our explanations of our model look when we have this leaky feature and the model relies on this one feature towards having the full picture of the correct one, you can see besides this balance being on the top, we also have everything else is a little bit mixed up. They overlap each other. They're not as clearly splitted as the one on the right. So for our use case, now we want to think about like what is important, because it will come back later. And we have this activity level. So if somebody was active on our website, our mortgage website, right, they were already checking out stuff a lot. So they had a lot of activity. They're more likely to churn. And if they're older, they're more likely to churn. And if the third one is the years until end of the fixed rate period. So if it's soon, they're also more likely to churn. So far, everything kind of for me makes sense. This is what I would expect from it. Also looking what we've seen in the EDA. If you've seen the plots, the churners were more on the right side, they were older, and the years and the FRP also were correct compared to this. So that's how we can look if our model did the job, right? On the left one, it didn't do this job because it was relying highly on the balance. But what exactly, let's move here. So, but what exactly are those dots on the plot? The actual aggregation of our local explanations. So this is every single customer compared to the full data set. And we brought for you here the one person that was misclassified, one that was a non-churner person, and one that was a churner person. And what we can see here, again, from top to bottom, we have the features that were the most important for that particular person, right? So it may differ from the global overall picture. And the blue arrows is what was driving for that person towards the non-churning side, and the red was towards the churning side. And you may also wonder what are those numbers on the bottom and the top. We're in the scale of logarithm of the odds ratio, so of odds of being a churner versus non-churner. So that's how the scale on the bottom is set up. And on average, right, the medium kind of value for the model is in the middle because it's a balanced data set and everything is perfect here. And the average, that's what the model has. And on the top is what was their probability of churning on versus non-churning. So this is the difference we're trying to explain with SHAP between the average here of this and where this particular person landed. And you can see that the non-churner is almost completely blue. So it can be explained quite nicely with all those features being very non-churny And yeah, this is in very short summary because we're a little bit short on time. What we can see here, you can play with it. You can try it with the other version with the when we had this leaky feature later at home. And we had also the bonus exercise. I would just quickly say like how it looks for us. It is a subset of specific people, but please just read it at home. It shows us like how the background data set works a little bit in SHAP. So in our case, we're using the full background data set, but if you use a subset, our results can look differently. So it's important to read it through later. So we can move on now to the second exercise, and Petra will reintroduce it.
So the second exercise, you will also work with SHAP again, but then you will have more on the feature interactions. And then the first exercise, you are going to use a dependence plot, so another way of visualizing SHAP results, and also with the use a dendrogram to make a plot of the top two clustered features. Maybe you say, oh, that's very vaguely, but if you read the exercise, I think you will manage. And secondly, as you might notice from the EDA, we don't have any correlated features. So we generated some correlated features in this exercise, and then you can see what's the influence of those correlated features on the SHAP plots and values. So yeah, it's up to you again. So in 10 minutes, because I think we will discuss the results again.
And then they don't do third one, right? I will just go and explain the results immediately. We don't do the third one, we just explain the
Yeah.
results. That was a question.
Julia, I'm online again, I think.
Yes.
Okay, let's explain the solutions about exercise 2. Are you all ready for it? So this is just a short reminder of what the two or the features are with moderate correlation. And then we make a dendrogram, and here you visualize more what features are grouped. So the first cutoff is from activity level and use calculator. It's at 0.8, but also this one is close into being second. So we use this dendrogram to make a graph for the mean SHAP values. And that's another way of visualizing your SHAP results. So that's what we're doing here. And the mean SHAP means that you take the absolute values of all the SHAPs for a feature, and then you average it. So that's what the mean SHAP is, and that's why you only see the red bars instead of also the blue bars that you've seen in the other pictures. And here you see the 0.8 clusters. So activity level and used calculator are here together with age. And you can also see that activity level and age have a high mean SHAP value. Then we make a dependence plot. And we use the two features that are already correlated. So if you have use calculator, so 0 means that they didn't use any calculator on the website, then you see that the Shapley values are also close to 0 or slightly negative. Whereas if the used calculator is 1, you see a difference, and then you can see that the SHAP values are positive. So here you can really see a difference if you use the activity level and use calculator. So then we introduce the correlated features. And here in this plots, you can see the difference, especially in the right plot, because here we introduced the correlated features. And you can see that here it's not a really good distinction between red and blue. They all plotted over each other. And this already shows you that these are noise features. And you can also see that the order, especially in the bottom part of the features in the SHAP plot, will change. And although this correlated noise may still be important, but these features might occur less frequently. And for example, you can play around with a lot of features in here. We just picked 2. So we did it on age and the correlated noise and correlated noise age, sorry. And there you can see that the correlated noise age doesn't add anything to the plot. So XGBoost already controls for that it's redundant and doesn't influence the Shapley values in this plot. And finally, we plotted just for the exercises the 2 correlated ones, and then you can see a completely different picture, and you can see that it's really a noise picture. So yeah, you can just play around in this exercise with a lot of features and how they are plotted against each other. But yeah, this is the ones that we picked for the solution for the exercise. And we also want to come back to the question about the categorical variables in your SHAP. You can use one hot encoding for it, and then it's treated like a binary variable in your SHAP. So, Magda, exercise 3.
Yes, so since we are kind of at the end of the time of the workshop, we're gonna switch it around, and I will introduce you what is the exercise 3, and I will show you the solutions because it actually runs quite a bit, and we can also just after we finish up, if you want to run it and see how it works and ask us questions, we can just do that for the people who want, so to not hold everybody, right? In this third exercise, we'll do it already here in the notebook. So we had all those Shapley values, right? They were going to very high and very low. So they kind of extract us the information about what's important and what's not important. But we want to make those business decisions. So we want to know how we can convert it back to our stakeholders and tell them what are the likely people to churn. So what we can do, take all this high dimension data and squish it to 2D. So it's easy to see and it's a little bit easier for the eye to understand what kind of groups we can have. So you can do that with UMAP, which projects into 2D our high dimensional space. And then we continued with using HDB clustering to identify the groups, because you will see that there will be plot with groups and it just labels the data for us. So we know that people are assigned to this specific group. And then that's how it looks. So, right, we had all those beautiful SHAP plots, but now we grouped them. And you can see on the left, this is a group of people in this that is already labeled by our HBDSCAN, and in the top left corner. And if you look on the right side, we collage those groups by their being churners or versus non-churners, right? So people who are gonna leave us and people who is not gonna leave us. So, and that group in the top left corner is actually green on the right plot. So it's full of people who's gonna leave. So we will want to know who are they, right? Who are these people? And for example, people on the bottom right are fully blue. So it is also another cluster. And so it means this is the people who most likely gonna stay, who are gonna stay, because this is real labels. And this is our non-churners, right? So that doesn't tell us anything, actually, right? If you just look at this plot, you're like, okay, I have groups, but what now? So what you can do now is you can, for example, just go and check all those different features and see if they reflect into groups as well. So here I plotted for you activity level, that we remember it was one of the most important features, and it was making high values were meaning people more likely to churn, low values less likely to churn. And exactly, again, on the top left corner, we have people with a high activity level of 4 and 5. So our churning group has this characteristic of high activity level. And on the right side, we have those less likely people to churn, and you have the low activity level. So you could go on and start trying all those features and try by hand describing what are the characteristics of those different groups. But what you can also do, you can use a package SkopeRules that takes where we take the cluster and we label it as 1, and everything else is 0, right? Else is a 0, all the other customers. So we're comparing this group of people towards everybody else. And when we run this, our churning group, right, was this one. So it was number 1, and this package identified as the most common in the logical features for this group. And its group consists of 82% churners. So this is the people who want to know who they are. And they usually have the high activity level. They are by 1 person, because we could have 2 or 1 person in a contract. This is one when it's a 1 person. And they did not take a loan recently. So that's example of like how we can identify. You can tune how many you want of those rules. and how you assess whether this is sensible for you or not. We have a precision in recall, so it means here we can see that they're quite high. So it means that everybody that were in this cluster had these characteristics, but there was probably like a one person, right? Because we have 99.8 was also with these characteristics was outside of this cluster. So you can go one by one and try to characterize this plot. You can also go on and drill down. And for example, when you have 40% churn rate within this group, try to now look into people where we have a target of churns, then to identify further with this characteristic, like who are the churners within this. So it's all in our extended version. So you can check yourself later what else you can do with it. Or you can just build classes based only on people who is going to leave, and then just look only at those groups. So there's many things to do. And then when we have this information about our customers, we can start planning what to do with it, right? Because maybe you want to send them different campaigns depending on their characteristics. If they're young, maybe they want to send something else than when they're old. So this is an example of what we can do with this. And I will now return back to summary of AFIC. Wait, I'll go here. So, this one. This
the last one here.
Yeah. Okay, wait. This.
Yeah.
Okay. Let's move here. Oh no, it's fine.
Is it okay?
No, yeah, everything's fine. Yes, everything's fine. I hope everything on stream is also fine because I closed something. So yes, so to summarize the learnings that we had today, right? First, we used in our exercises XGBoost, but you can actually use any other model you want to use. So it works with basically almost, I think, all models or almost all models. Maybe the newest one doesn't work with yet. And then you have the same kind of representation. So it's then you have to learn only once how to read the plots. Then we have also the we had the first exercise when we're looking at the local and more global representations, and it's very helpful because it helps us to investigate our results on a different levels. So we can, for example, look into who are what were the reasons for the misclassifications. So it's for that, it's very nice to have it. And then in the second exercise, we would see how we can use it to go more deep into this feature interactions and what happens with correlations, and investigate the things that are not as easy to look at in just with EDA when we look only as in the for the features in silos, right? We now can look at the combined view, but it can be sensitive to correlation, and it can be a little bit more messy then. So always important to remember. And then also it cannot be used, when we see those plots, they don't tell us if we would move one of those features a little bit here or there, that something would change for the customer, right? So it's not a counterfactual explanation. And it also doesn't tell us the reasons, it just shows us the correlations with the data. And finally, the thing that you just see now with our exercise 3, it's those plots. If we learn how to use them, right, they can be easy for us. And then they give us a lot of input to audit our models. But we still want to be able to run some business decisions, not us, but our stakeholders will want to. So this is what SHAP doesn't provide. And that's when you start, right, going outside of it to try to transform it towards those visualizations. And I switch mode. Oops. Oh, and I also added a slide.
Yeah, you have to go.
Yeah.
Now, the PowerPoint.
Yes.
And click that one, and then you can go.
Yes. Okay. Well, yeah. This is the slide I added. Yes. So what I would like you to take home with yourself after this workshop, or explore more when you get home, is to remember that explainability is actually an essential part of our data science projects, because it's important to understand how they make the decisions and how they align with reality, if they make sense. Because when we have those clear explanations, we can bridge the gap between the complex models and what we and our stakeholders actually need. Because engaging with our stakeholders is also important to be able to address their insights and their concerns throughout the project and make sure that everything is aligned with their objectives. And to achieve this, we also seen that we need EDA to see that everything we do makes sense in reality. Yeah. Last but not least, it's important to remember that SHAP is not the ultimate solution. There are different tools for different needs. So if you need, for example, the counterfactual explanations, you need to go for a different package. So it provides valuable information, but it's not our only tool. And you should always choose your tool based on your needs and understand its limitations to have a full picture. Yeah, I think I do it again. No, yes. Yeah. So I wanted to just thank you all for participating, and I hope you go on and try to learn more and do the exercise we didn't have time for doing. And also, we wanted to thank more people.
Yeah, first of all, of course, PyLadies for hosting, let us host this workshop. Also for Glanda, she sponsored this event today. And we also have 3 ladies in the room, Olga, Anna, and Bianca, who arranged this venue, but also ordered food and drinks for all of us. And of course, our colleagues, Solar, Dana, Merel, Dana, Niet, I don't see her. Oh, there you are. For helping you throughout the workshop. And like Magda said, of course, we're happy that you were all here, and hopefully you learned a lot. So let's enjoy drinks and foods. One last thing.
Yeah, and one last thing. So thank you for being here today. As mentioned, we'll continue with food and drink in the meantime, but we need to close the streaming part. So just a bit of shout out about upcoming events. So for those who joining us the first time today, we run monthly workshops. So usually it's 3rd, 4th week of the month, Tuesday, Wednesday, or Thursday. So the next workshop would be in-person event. It would be at the Booking.com office, and it would be with a topic of LLMs in action, how Booking.com scans, detects, and monitors fake and unsafe content. And then in December, we're going to have from 3 to 6 December, we're going to have a PyLadies conference where we also planning to present one of the really, really interesting workshops from our site. So that's from our side. And I also want to give a mic for this person, just go here. So we love PyData Amsterdam community. We were parts of the conference. So, and we have a person from PyData Amsterdam. So
we love
here, like the camera is here. Yeah, so tell about the next event.
Yeah, so thank you. So I hope you enjoyed today because we have more, right? We have more on Thursday. On Thursday, we are having a PyData meetup. And Baz, who works here at ABN Bank, will be also presenting what he has been working on regarding marketing. So I would love to see you there. And yeah, thanks for tonight. Yeah.
Thank you.